Now that you can use events to cue and synchronize actions in your programs, it's time to dig a little deeper. Events aren't limited to the green flag. Sometimes events can be used to allow the user to provide input for your program to make it interactive. In this lesson, you'll learn how to use text, key presses, and mouse clicks in your programs. To recap what we have talked about up to this point, we've created programs that deal with output, processing, input, and storage. And we'll focus more on the last two topics in this lesson. To give output some review, the definition of output would be observable behaviors generated by the computer. So as an example, we know that we can make our cat say something. We can make our cat say hello, and we can see that on the screen, and it's an observable behavior. We can animate, we can make our cat move. We know that there are sounds associated. So something that can be observed by the user would be output of our program. Processing is instructing the computer to do some sort of calculation. Now, we're not talking about complex mathematical equations necessarily, but usually there is something mathematical involved in this process. So, for example, when we want to adjust our location, we want to set our sprite's location using the 0, 0 point, and we want to point it in a particular direction. So we are telling the computer that wherever you're at, you're going to have to move however many pixels it takes to get back to 0. And the computer will do that for us. So that's our processing. But now let's talk a little bit more about user input. So the definition of user input would be user interaction with a program via either clicking, mouse movement, or keyboard entry. So as an example, we know that it's good to have all of our action in our program start with a green flag clicked. And that's the user. The user is the one who has to click the green flag. Nothing will happen until the user does that. The user could also maybe use an arrow to interact with the program, or the user could type something when they're asked a question. And different types of input that you encounter, not necessarily in a computer program, but just in your everyday life, would be what you eat and drink. That's input. What you see, what you hear. Those are all kinds of, inputs that you take in your daily life. So back to Scratch World. For user input, we can take event blocks located in the Control tab, and they have their own section of the menu in Scratch. And basically the events that are there, some of them are just a single event, like when this sprite clicked, there's nothing to change. However, many of them can actually be changed. For example, a keyboard key being pressed, and you can see that there's a drop-down menu where you can select which key on the keyboard you want to specify. We are going to talk a little bit more in one of the activities about using the arrow keys, and you would have actually 4 separate events, one for each arrow key, and we'll talk a little bit more about how to program each of those things. So one of the things that you'll need to know when you do that activity is that when we want our sprite to move in a particular direction, for example, down with the down arrow, we have to make sure that our sprite is pointed in that direction. Otherwise, when we press the down arrow, our sprite, if we just tell it to move, it'll point whatever way it was pointed before. And if it was pointed up or left or right, that's the way it's going to move. So you'll need to use the point in direction command in the motion tab. So, as I said, you're going to get a chance to try it out. So now you are going to experiment with user input to move a sprite. So the definition of storage is what the computer needs to remember in order to execute the program. So in other words, the program instructions, which it has to remember what it's been told to do, and the state of the sprite or whatever it is that we are programming. And we'll talk a little bit more about what that means on the next slide. But just as a quick example right here, Scratch the Cat, the move 10 steps command requires that the computer has to understand where the sprite is so that it can move 10 steps in whatever direction the sprite is facing. So if the sprite is facing right, that 10 steps is going to change the X position. It's going to move to the right relative to the X axis. So the computer has to know both where the sprite is and the instruction that how many it's supposed to move, how many pixels. So state, we said we'd address that a little bit more. So state refers to the attributes that describe what a computer is doing at any given moment. So we can think of this in Scratch as tell me everything that describes the way my sprite is right now. So that includes the X and Y position, that includes what direction is my sprite pointing, what costume number is my sprite wearing, what is the current size, what current volume will my sprite make their noises at or their sounds. So anything that helps to describe how the sprite is at this very moment. So what is the difference between position versus state? So in Scratch, typically a sprite is going to, when you import a new sprite, it is going to go to the 0, 0 point on your screen. So of course the X coordinate is going to be 0 and the Y coordinate is going to be 0. And so what is the current state of your sprite? Well, that is its state. It has those current X and Y coordinates as its state, and those also describe the position. But chances are very high that you do not want your sprite to stay at 0, 0 for your entire program. It doesn't seem like it would be very exciting to watch. So what we need to know is that when we want our sprite to move, what we're actually doing is we are changing the state of our sprite. So here's a set of instructions. We can see that we have an event that is up here, and it says so when the up arrow key is pressed. Now, fortunately, it also includes the point and direction. I know that this 0 is actually up, and if you haven't played around with that, just to show you, 0 is right here, down is right here at 180, and then we have 90, and over here there is negative 90. So that's why up is 0, just in case you're wondering, and down is 180. So in any case, this does show us correctly that our sprite is going to point in direction up. And then once all that has happened, it is going to move 10 steps. So we are changing the state of the sprite by changing its position. And specifically, if you think about it, when the sprite moves up in an upward direction on the screen, really what we're doing is changing the Y coordinate by a positive number. Otherwise, our sprite would be going down. Those are the attributes of the sprite that we're changing. We are changing the direction, and we are changing the position. So Scratch, again, uses the XY coordinate plane to indicate the location. Each sprite has 3 attributes that directly relate to the location or the position of the sprite, and those are the X position, the Y position, and the direction. And you can find all of those in the Motion tab. You might have to scroll down a little bit when you get to the Motion tab, but it will be there. Try all of this out on your own, and good luck. All right, so let's go back to text input. Input in general, we've talked about, is something that the user does to interact with the program. But specifically, text is a type of input that the user can give. And this type of input relates to the topic of variables, which we're going to cover in the next lesson. But what you need to know now is that text input can be saved as a variable. And these text inputs, they can change, the value can change, and they're basically serving as a placeholder. So you can see that if you had a variable called name, who knows what the name would be. Maybe it's the name of the person using your program, maybe it's the name chosen by someone to play as a certain character, but the name could be set to one name, and then later in the program could be set to a different name. So that input can change. What does this mean in Scratch? We have already used text output with the say. We already know that our cat can say hello for 2 seconds and actually say whatever we type in that box. But we can actually ask our user to interact with our program by typing an answer to a question, providing the answer to a question. And this is done by using some things located in the Sensing tab. So the Sensing tab is the turquoise palette, and you might have to scroll again a little bit just to find where this is, but there are 2 really, really nice features in the Sensing palette. Ask, that's right here, and the answer. And You might notice that the ask looks more like a command, like one of the puzzle pieces, and you'll see that also you can type in it just like you can type in the say block. So you can type a particular question, and then you can wait for the answer. And Scratch already has a way to make sure that the answer can be saved, at least temporarily. Like we talked about, we can save text input. In the next try it out, you will get to decide a question to ask and practice putting in the answer, then being able to actually use that answer in your program. See what happens.